Hello YouTube, this is umills03. So now we've made it to lesson 2 of the Python curriculum. And in the previous two videos, in lesson 0 and lesson 1, we've done a couple of things. So what I described is that I had already created a programming playlist for Java programming. And so if you want to go learn Java programming, if you were inclined enough, you could go do that with about 45 videos, each 20 minutes long. And I said, well, I can go ahead and do the same thing in the Python universe, because some people really just want to learn how to use Python. Maybe they're university course is going to be in Python or something. They said, I don't really care about the Java syntax. I just want to learn Python. So what we did in lesson 1 is we figured out how to download. So we already downloaded the downloaded the IDE, the PyCharm IDE in lesson 0. And we said the first thing, the only thing we're going to do in lesson 0 is download the integrated development environment, the software programs that we can actually start writing these programs. And then in lesson 1, what we saw in the previous lesson is that we can print statements to the console, and we do that with the print function right here. And we say print with parentheses, and then what we need to do is have quotations, and we're able to print strings. And so this is just sort of a review from the previous lesson. But if you say Tim is 36 years old, and then you go ahead and print this to the console, then indeed we run the main method, and you can see the file that it's running. So it goes into the directory where the file belongs, and then it just runs Tim is 36 years old. And we said you could also have single quotations. So then if you go ahead and have single quotations, then you'd get the exact same thing. And just to demonstrate that, let's just change that number. So hopefully the code will update here. Now it says Tim is 37 years old. We also said that you can stack statements. You could say Renee is 22 years old. And then here, if you just have 2 consecutive print statements, now if you go ahead and run the main method by going up to run at the top and pressing run main, you would see both of those lines of code printed. We also talked about comments, and we brought up this notion of Python enhancement proposals, so PEP8. And basically what PEP8 is it's a way to basically have good etiquette in a programming language. There's a distinction to be made about the rules of programming that you need to follow by virtue of being in a particular language, and the etiquette that would be sort of typical or preferred of most programmers in the language, but wouldn't be the difference between make or break of your computer program. So let me show you what I mean by that. In the previous video, we saw that comments start with a hashtag. Okay, so this would be an example of a comment, and this is basically between you and me. This is for 2 programmers to make better sense of the code, but it's not interpreted by the compiler. And you can see that it underlines it in gray. So sometimes we're going to have lines of code underlined in gray, and that's sort of a PyCharm thing. So this is something that the IDE has decided to do. Is basically what it does is it says, okay, if an engineer is writing Python code in my integrated development environment and they do something that's a little anti-etiquette or unorthodox, I'm going to let them know. So what's the issue with this comment? There's no issue with it with a capital I. It wouldn't prevent the code from running. But what would happen is it gives you a suggestion. So it says, well, typically with our etiquette, we like to start a comment with a hashtag and then a space, okay? And then if you go ahead and put the space there, then it says, oh, okay, that's prettier, right? But then if you didn't have that space, there wouldn't be any issues with compiling, and we could still see our code run, right? So we could still go ahead and say run main, but you know, you just have that, basically you have a warning here, okay? And you can just take a look at that. And that would just basically be a suggestion. So it would be looking at the suggestion, it gives you a light bulb. It's like an idea, right? And basically what option it'll give you is if you don't want to have errors like that called out, and if you don't want it to take issue, if you don't have a space between a hashtag and the capital I, for God's sake, then you could go ahead and say ignore errors like this. So then if you did that in subsequent versions, if you did that further down the code, then it wouldn't underline in gray. It would say, okay, this programmer doesn't care about that, so we're not going to take issue with it. But then what we're also demonstrating here is we're demonstrating that we're reviewing an arithmetic expression. We said Python is able to evaluate not only strings, not only can we print things on the console, which is, you know, super cool and all, but we would also want Python to actually do things and make calculations. And we said, indeed, the Python interpreter knows how to add 5 to 5 and get 10. And we said that we can do the same thing for multiplication. So now if we go ahead and stick a different operator in there, we get 25. You can stick another operator in there again, you get print of 5 minus 5, you get 0. One of the things we talked about in the previous video is division. And we said there's one key distinction to be made between Java and Python. So what we're going to do is we're going to say in Java, an int divided by an int is an int. So what you would do is you would say 5 divided by 4 is 1. Okay, 8 divided by 3 is 2, because there are 2 full groups of 3 in the number 8. And then you'd say 100 divided by 100 by 10 is just a perfect 10, right? In Python, a number divided by another number gives the decimal representation of the result. So if you're talking about Python, what would be the corresponding example? So for 5 over 4, you'd be talking about 1.25. For 8/3, well, that's like 2 2/3. So what would that be? Like 2.66667, right? And then it would have a certain amount of precision. So it would give you a certain number of decimal places after the radix point. And then 100 divided by 10, what we saw is it's actually going to give you 10.0. So even if there is a perfect division, what we have to understand is that Python is going to give you a floating point number as a result of division. And so we can go ahead and verify that for ourselves. So we could say something like print of 4 over 5, and then we're expecting the decimal number 0.8. There's no issue with that. But then if you did have a perfect division where you said 4 over 2, instead of saying 2, it would say 2.0 because it just automatically does a conversion. And it says if you divide an int or double by another int or double, right? If you divide an integer, a floating point number, by another integer, a floating point number, Python will return a floating point number, a double. And then the last thing we said in the previous video, before we can go study some more of these arithmetic expressions and concatenating strings and really getting onto the new content, is we said that Python prefers floating point numbers over integers. So basically what you could do is you could actually try adding two values of two slightly different data types, and we saw that in the previous video. So what if you try adding an integer to a floating point number, but the floating point number is sort of like an integer. So the 77.0, it's a decimal number, but it's really not that different from 77. So the question is, would we get 83 or would we get 83.0 as the third line of code being printed to the console? So now if you go ahead and run main.py, the executable Python file, you see 83.0. And that's because, like Java, so this is a similarity between Java and Python, but what's common between the two languages is that both of them prefer doubles or floating point numbers over integers. Okay, so hopefully you understand that that's what's going on here. Okay, so that's what we have going on here. And so what we could do in this line is we would say Python prefers doubles, which we say floating point numbers or decimal numbers, if you will, it's all saying the same thing, over ints. So whole, you can think of that as whole numbers or integers. Okay, so hopefully you can understand that. Hopefully you can see the rest of that line of code there. Okay, and then it's already saying this is another example of a PEP issue. So what it would do is it would say, well, your code's still going to compile. There's no problem with what you wrote here. But typically it would be good etiquette. It would be a little bit cleaner if you had two spaces between the end of the line of code and the command. So now it's giving us another issue here. So then if we scroll back over it, it says that the line is too long. So this is another example of etiquette. And we're going to be seeing these little PEP things, these little Python enhancement proposal suggestions, right? And we're literally too long by one line, and it wouldn't have an issue compiling, right? So you can still compile it and it still compiles, right? You change this to a 79, you're going to get 85.0, right? It's still going to compile. It's just saying, well, that's sort of a long comment and it's not the prettiest line of code. So maybe, just maybe, you want to consider doing away with that and making it shorter. So all we would have to do is like delete the whole numbers here. You just call it integers, and then suddenly the comment is no longer too long. So that's essentially what we have going on here, and that's an example of a Python enhancement proposal. It's just a suggestion. It's just saying, hey, I think your code would look a little bit cleaner. It's just a suggestion if you go ahead and have the spacing properly here, right? And that's up to you whether or not you think that's important. Do you want to adhere to those suggestions, or you say, why are you calling me out on the number of spaces I have between these two parentheses? So that's up to you, okay? And then if you go ahead and look here, I mean, this is just Python enhancement proposal. So this is just the nature of the PyCharm integrated development environment. It's a characteristic of the software program that we're writing the code in right now. It can even kind of detect that we might have spelled representation wrong. So typo and word representation. It's just kind of cool, right? And it's some of the architecture, it's some of the logic that's happening behind the scenes. Is it says, maybe you spelled that word wrong. And this is in a comment, right? So this is in a comment. Python doesn't care. Python's not going to read and interpret this, but just for the programmer, they say, oh, well, maybe in your comment, you spelled one of the words wrong. So I think that that's kind of cool. And then you can decide what you're going to do with that comment. So what you could do is you could replace it with the suggestion that they give you. You can just click this blue hyperlink and it'll go ahead and replace it. But then if you click more actions down here, oh, maybe you meant a different word. Maybe you meant representative. Maybe you meant representations, right? and then you could go ahead and decide what you wanted to do with that, or you could ignore it altogether. So you could ignore types of errors like that. But then what you could do, so then those are examples of arithmetic expressions. So we've talked about how division works, and we've talked about the conversion of an int to a double if you're adding an int and a floating point number together, right? The fact that the 6 is automatically converted behind the scenes to a 6.0, and then Python knows how to add two floats together. It says 6.0 plus 79.0 is 85.0. There's no problem. Let's talk about exponentiation. What if you want to raise one number to another number, okay? So in order to raise a to the b, we will write print of a times b. So it's basically those two asterisk symbols right next to each other. So then what happens if we want to know 10 cubed? So if I multiply the number 10 by itself 3 times, what would be the result? And then we're going to go ahead and print that, and we see the 1000, okay? And you could do this for different examples, right? So 5 squared, you would expect something else. Now you'd be talking about 5 times 5, which is 25. If one of the numbers is a floating point number, your result will be returned as a floating point number. So let me show you what I mean by that, okay? So if a and b are both integers, then a times b returns an integer, okay? But if either of a and b, so at least one of them, are floats, right? So decimal numbers, then a to the b, right? A times b, if you will, returns a floating point number, returns a float, okay? So here's what's going to happen. What we're going to do is we're going to say 5 to the 2.0 power, okay? And so then what you go ahead and do is you run it, and instead of getting just 25, you would get 25.0, because it says that what we're going to establish, the theme that we're establishing here, is that Python and other languages, Java too, prefers floating point numbers, the 2.0, over the integer. So it says, I don't really know how to raise an integer to a floating point number, but I do know how to raise a floating point number to a floating point number. So what if I just automatically convert that 5 to a 5.0, and that's what happens here, okay? What if you went ahead and said something like 81 times 1/2? What's going to be printed here? Well, 1 over 2 is recognized as a floating point number. We said that if you evaluate 1 over 2 in Python, you get 0.5. So you're raising an integer, 81, to a floating point number, 0.5. And we said that if either of a and b are floats, then this is going to return a float. If you think about in mathematics, if you raise a number to the 1/2 power, that's the equivalent of taking the square root of it. But instead of printing just 9, which is the square root of 81, we would print 9.0, which is the floating point representation of the square root of 81. So now if you go ahead and run this code, hopefully you would be able to see that we would get the 9.0 that we're looking for. And hopefully that's sort of clear to you what's going on with that. We can also talk about the difference between we can also do integer division. Okay, so we've already been talking a little bit about division, but what I want to do is I want to bring up another point here. So in Java, you know, an int divided by an int is another int, right? We said that Python evaluates the result of, you know, the division of two ints as it would happen mathematically, right? So 3 over 4 would be 0.75. Python integer division requires you to write a over b for two ints, a and b. So if you want to do integer division and you just want to know the number of full groups of b in the number a, what you're going to do is you would just have 2 slashes. So for example, if you say 26 over 10, this would tell you, you know, this would print the number of full groups of 10 in the number 26. So then if you go ahead and run it, then you would go ahead and see 2, because it says 10 goes into 26, a total of 2 full times, okay? What if you make one of those numbers a floating point number? So what if you say 26.0 divided by 10? So if you make either of those numbers 0, it's going to convert the result to a floating point number. So a over b returns the integer division of you know, of a and b, but it is converted to the floating point representation of that result if either of a and b is a float. Okay, so hopefully you understand what that. Let's see another example of that. So let's do 303 divided by 100 divided by 100.0. So this would say how many full groups of 100.0 are there in the number 303, but then we're going to go ahead and convert the result of that to a floating point number. So that's why we get the 3.0 there. We can also talk about modular arithmetic. So we use modular arithmetic. The percent sign returns the remainder when A is divided by B. Okay, so essentially if you say something like print of 26 mod 5, this would print 1 because 1 is left over when 26 is divided by 5, right? You would have one number that doesn't go into the, you could get 25 from the groups of 5, but you couldn't get the 26th one, right? So we would be expecting to get a remainder of 1 here. And then if we go ahead and print this code and we run it, indeed we get the 1 there. Okay, so essentially that's what's going on here. The same thing can happen for floating point numbers. So what if you went ahead and said 1.3 mod 5? Well, this would be the remainder if you divide 1.3 by 0.5. So how many full groups of 0.5 are there in the number 1.3? Well, 1.0, that would be 2 full groups of 0.5. But if you go up to 1.5, that would be 3 full groups of 1.5. So you know that the remainder is going to be 0.3 because that's the amount of the 1.3 that doesn't make it into the 0.5s, okay? And this is an example of a rounding error, right? So this is an example of something that happened where Python tried to evaluate it, but you see just this kind of trailing digit way down here. But since it's so far down from the 0.3, it really doesn't affect that number at all. So that's just an example of modular arithmetic with floating point numbers, right? What if you said 101.0 mod 10, and then it would give you the 1.0 because one of those numbers is a floating point number. So there's 1.0 hanging out, you know, that wouldn't be covered by the groups of 10. One of the things we talked about in the previous videos, we said that we can go ahead and print statements either with single quotes or double quotes, okay? So hopefully you're familiar with some of these arithmetic expressions, which we'll be reviewing and studying in previous videos. But what we could do is we could say something like we could say something like David's book, okay? And so what the issue here would be is if you wanted, basically, if the book belongs to David, you'd want to have an apostrophe here, right? And you can see that this string has double quotations in it. So it wouldn't actually be a problem for you to put a single apostrophe in here because you're making a distinction by using double quotes to envelop the string, the words that you're trying to print, and a single apostrophe, which is just taken to be that. It's a single apostrophe. So this would not be an issue. You could go ahead and say print David's book. And similarly, right, if you wanted to say quote unquote, you know, what if you started with single quotes? So what if you said quote unquote the apple, right? And then this would not be an issue either. If you start the string, if you start the sentence with single quotes and end it with single quotes, then it's okay to have double quotes within. But what the issue would be is if you combined those sets of quotations. So this is called, what you need to do is you need to have something called a delimiter. Okay, so let's say we want to write David's book, but we want to do it with single quotations. What we need to do is we need to actually have a backslash for right in front of the apostrophe that we do want to have printed literally. So here's what I'm saying. So this string, what we're going to try to print, we're going to envelop it in single quotes. But then how are we going to be able to get the apostrophe between D and S? Because if we envelop it in single quotes, then basically the string, the statement would stop after that D, right? It would say, oh, look, there's the next apostrophe, so it's time to end the string. So the way around that is to basically have a backslash. This is called a delimiter, and it says for the next apostrophe, I don't want you to end the string. I don't want you to end the word. I don't want you to end what I'm trying to print. I want you to literally print the apostrophe. So just normally take this as a standard apostrophe that should be printed to the console. And then what you could do, right? And then you could go ahead and run it. And this would be an example of a delimiter. And now you can print David's book using single quotations. The same thing would happen with the apple. So what if you wanted to print the apple, but literally printing those double quotations? So what you would do is you would say the with double quotations, and then you would need a delimiter every time you wanted to actually print double quotations. So you can see the two delimiters here. It's going to print those double quotations, and then the green double quotations are what's actually beginning and ending the thing to be printed. And so this would be able to print the apple. So that's an example of what's called a delimiter. And as long as you put a backslash, that allows you to distinguish an apostrophe, a single or double quote that you want to print, from the single or double quote that was responsible for starting and ending the thing that you wanted to print. So hopefully that's helpful, and we'll be talking more about strings and combining strings in the next video. So from UMills03, thanks for watching, and please subscribe.